Hello and welcome to our presentation for Group 15 for COMP283. It's the final assignment presentation and this is based off our report. Okay, we'll start with an introduction to the scenario from last time as well as now, and the database design from last time as well as now. We'll have two proposals for how we were going to amalgamate the systems. We've got to, breaking it down to the hardware and the environment they use, the continuity plans of the businesses, and the summary of each one, finalised by a conclusion. Okay, the Roxy. For those who weren't there last time, I'll explain this one. Basically, it was a small cinema, and we had to expand it from how simple it was. It was a privately owned cinema somewhere in Liverpool, and it holds 3 screens, so a large one and 2 smaller ones. We had to split it up in between tickets from old people, senior students, children and adults, and obviously there was a premium cost as well. And what we did was we basically set up a database system that worked with this and allowed it to expand in the future as well, obviously keeping it realistic with the money as well, and the actual configuration itself. Okay, this is the actual ER design of it. As you can see, it was a lot different when it first started, and this was the finalisation of it. So there's no plurals, there's no foreign keys, everything's a primary key. So everything's very set to the screen, to seat reserved, movie to performance, to seat reserved, review for an employee, to tickets to prices from the customers, and how much snacks were actually sold. So what we wanted to find out on the previous example was how much basically the cinema was intaking as a profit. So that it could mean from snacks, how many people were reserving seats, to any sort of query like that. So how much was being spent on tickets, with the fact that snacks were being eaten, and how many seats for a specific performance were being allocated, let's say, on a premium seat. And that pretty much did it, by the way. That was a good example. This was all of our diagnostics for the actual our database system, and I'll give you some of the general specifications now. So the database server that we used for the actual cinema was this one. It was connected via the internet, of course. The cinema information and the custard ticket information will be stored on this one. And the manufacturer of this proposed equipment would be obviously reputable and globally recognised, because we don't like to black people. All of our software is genuine software, and the regular plan was to update it back up once a month, and it'll be stored on a separate terabyte hard drive. We extended it from the original one, it was only 1, we had to put 2 just for realistic options. Sorry, just go back a second, sorry. We had to include the new operating system for the new servers, for the new database, which is Windows Server 2016. It upped the price by £650, which in total now is £1,361. That's where we're at now with our database system. Okay, now we need to set up the database itself. So the configuration of how we do this. So you select the actual development machine option. You enable the actual networking for TCP and IP networking, ensuring that the checkbox is selected, and you specify in the options below. So the port number, the default setting is 3306, and open the firewall port for the network access so we can actually get access to the system. At the second MySQL Server configuration page, you set the following options. So the root account password. So the root user is a user who has full access to the MySQL database server, and the MySQL user accounts is your new username, Roxy Cinema, password. This is all our initials, but just to say, for an example, this is the password. And at the third MySQL Server configuration page, Windows Server's name, and start the MySQL Server at the system startup. And for MySQL Server's default character set, choose best support for multilingualism, I can't even say that word, multilingualism UTF-8, so make sure it's compatible with all characters. Okay, the first proposal, away from the past and into the future. So database server hardware. Firstly, our database server hardware, we already designed our previous business model, is going to be used. It's pretty much similar. So, but according to the new task, we will merge these with a similar organisation's database system. But based on our previous estimate, the size on which we need for one cinema, we believe we've got a big enough one so we could merge 2 together for 2 database systems to come together. The environment, I will explain this. So secondly, about the environment, we choose Windows Server 16. During the discussion stage, we had two plans. The first was to use a Linux system, and the second was to use a Windows system. Okay, both systems different. They both have their advantages and disadvantages, which I'll explain. The biggest point about the Linux system is that it's free, and if we use this system, we will save the budget. And our company is a cinema company, and many powerful and convenient features of the Linux system we might not actually use, which would be a waste. And the Linux system is obviously not as good as the Windows system in terms of a graphical operation, a visualization. So under the trade-off, the cost of operating and maintaining a Linux system is obviously much higher, a lot higher, than the cost of purchasing a Windows system. From the point of view of a system usage, we can use the Windows one, and this is enough to meet our needs for the operation of the cinema database, and it can reduce our costs of the database system and our costs for the database administrators. So in summary, we discussed it, and we finally chose the Windows system as our database operating system. Okay, the business continuity plan. The actual method used. Okay, so we chose database linking for this proposal based on the assumption that both organisations use MySQL as their database management software. The key personnel in this one would be, of course, the database administrators, which I will abbreviate as DBA. Plays an important role in database management since the connection requires a username and a password, and the DBA is necessary in these steps stated below, which I'll go through now. So a checklist of steps. Okay, we've comprised of 3 steps. So you create a table on the remote server, or use an existing one. You create an identical table on that local server, and then you add a connection information to the local table to link to the remote table, either using a connection statement with the details of that remote server, or you use the existing connection from create server statement. So the details of costs, all in all, for this proposal, we estimate that the merge of these 2 databases will take a database administrator at least 1 week. And we also find that the average salary of one of these SQL database administrators is halfway between 30 and 31k a year, so £30,589. Thus, the cost of this work will approximately cost 640 quid, all in all, for this proposal. Okay, the summary of this proposal, all in all, of the first one. This is the database linking. The hardware we chose is to use what we mentioned previously, and we chose the Windows as our database operating system. The cost of the database server, hardware and environment is £1,361. That's ours. We use database linking as the approach to be taken to amalgamate the new one and our one. And moreover, we need the database administrator to handle the work required, which will up the price, and it's estimated that the work will take the DBA 1 week to finish, and the cost of that is £640. So from our old number to obviously the required number, the total cost for this proposal is £2,001. Okay, the second proposal, and this is going to be, I'm going to explain this one now. Database server hardware. As mentioned previously, we believe that we've got a big enough system that we could obviously migrate these 2 things together. And the environment, it's previously mentioned in proposal 1, nothing's changed. It was going to be Windows primarily. We're not going to sway away from Linux. Okay, the business continuity plan for the second proposal. Okay, the merge method used for this one was a manual migration, and this was based on the assumption that both organisations, so ours and theirs, use MySQL as their database management software, just like last time. So key personnel, again, database administrator, playing important roles as they usually do, but it all needs to be done manually this time, so it's a lot different from the previous ones. It's a bit more tedious, a bit more concise and strenuous. So a database administrator is necessary, absolutely necessary for these checklist steps, which I'll go through now. A lot more than last time, not just 3, there's a lot more. So examine every single table in our Cinema DB schema, so we know everything about it, which could take a long time, depending. Find all the tables that are commonly migrated, and find all the tables that have some specific rules. We've got to create a backup dump, a to-do list, execute migration on a test server, find the best ways to test it, and execute migration production server. So you're actually going through with the actual job itself. Could take longer due to the fact that obviously this might take more than 1 DBA, which I'll explain now. So the details of costs. Because of step A, more than 1 DBA should be involved to examine every table. So every single table created, a DBA will have to obviously check that. We estimate that the merge of the 2 databases will take 2 database administrators is 1 week. So not one DBA, 2 in 1 week, just like last time, but there's one more person. And we also found that the average salary of that was a course which we discussed was 30,539. So with them two combined together, and in that space of time needed, it's going to be 1,280, so double from last time. Okay, a summary of that proposal. So the hardware we chose to use was what was mentioned previous, and we chose Windows, obviously, of course, as the OS. The cost of the database server hardware environment was £1,361, as you know. We used the manual migration as the approach to be taken to amalgamate the two database systems, and moreover, we need 2 DBAs to handle the work required. It is estimated that the work will obviously cost us in the future of it is 1,280, as we said, but this will obviously push the cost up £640 higher than the first proposal, so this one's £2,641. Okay, to conclude, to summarise the presentation, we will analyse the advantages and disadvantages of these two proposals respectively. So database linking and manual migration, will confer which one's better, so to speak. Okay, the advantages. I'll talk about the advantages of the database linking first. It allows a local user to access a link to a remote database without having to be a user on the remote database. And the disadvantage, it does not support performing certain operations using database links, which means DBAs will not be able to conduct modifications to the remote database as much as they want. Manual migration, so the advantages and disadvantages of the second proposal. It allows DBAs to have full access to the operations that can be performed upon the database, as 2 databases will be completely merged by migration, but this takes more time to finish, as every table needs to be examined and the execution of migration will be done manually, which would take a while realistically. So in conclusion, we decided that we prefer database linking, this one here, because DB linking costs less and is more suitable for potential expansion in the future, whether that's more cinemas, that'd be nice, just keep going. But all in all, I do believe that is us done on as a group. Thank you.